Hello everyone, my name is Anna Schwetz and I'm a part of a GEM working group. In this tutorial, I'd like to show how we can use filters during the GEM Hackathon 21. In this tutorial, we'll be using one particular filter. It's a gender bias filter, which detects the presence or absence of bias regarding male and female groups. In a current dataset, it's a lexical-based filter and available for 4 languages: English, French, Poland, and Russian. So the process is quite simple. It has only 4 stages. Get the dependencies, install them, load the data, test the filter on a small amount of examples, and apply the process on multiple entries. So let's get started. First, we need to clone the repository. We need to go in it with cd change directory and install all the requirements. I've done that already, so I have my folder which contains the requirements which I've run already, and it meets the installation of all we need in order to use our library. I've already loaded data, and for this tutorial I'm using the Common Gen dataset. It's an English dataset for the constrained text generation. If you explore the data object received, we can see that we have several splits here: train, validation, test, challenge. And now if we retrieve the first entry from the train split, we can see that this is an object that contains several properties. For example, concepts, which are the array of keywords used as a condition to generate the sentence from the target property. And another important property here is GEMID, which we will reuse while constructing our final JSON file. So our goal is to retrieve the sentence itself, not the entire object, just its sentence. And we can do so with the application of the get method, giving the name of the property. Now let's do a small test on using our filter. In order to do so, first what we need is to import the corresponding object from the directory where it's stored. In our case, it's filters, gender bias, and here we have a filter.py file which contains the description of this class. We are instantiating the object given the language in parameter. We are precising the array of our sentences we want to test, and we are running the filter giving those sentences as arguments. So this filter returns true indeed, because we have 2 sentences being tagged as belonging to masculine group, only 1 sentence belonging to a feminine group, and this sentence is neutral, so it's not taken into account. So if we want to test it on the ConGen dataset extract, we need to construct our array of sentences, and we are doing so in iteration. We are taking the from the train split, we are retrieving the targets, and we do so 10 times. So in the end, we are receiving the array of 10 sentences. If you run the filter, we are still receiving true. Now we want to explore the statistic. So why is actually returning true on those 10 sentences? We can do so using the helper methods, count gender, but using outside of the class, we need to first receive the flux sentence. So we are receiving the flux for these sentences that we want to analyze. Then we are counting the genders, and we are receiving the statistics. And we see that indeed we have only 1 sentence that belongs to the feminine if you want to receive the actual sentences that are distributed to those groups, we can use another helper method, store groups. Again, we need to retrieve the flag sentences using flag sentences helper method on the instance of our class. And then we are receiving our three groups. Indeed, we see that we have only one sentence belonging to the feminine group, 3 to masculine group, and 6 to neutral group. Now we will be using those arrays, those newly constructed sorted arrays, to make the construction of our final JSON object. So this is the definition of the class that we'll call just a bit later. And what it does, it compares the train instance that we are retrieving dynamically with the feminine, masculine, neutral group. Why we're doing so? Because we need to get the GEM-ID out of those objects, so we can store them in our JSON. And in the end, we are storing those arrays in the corresponding fields, constructing the final object and returning it. So here we are calling this create filtered user-defined function we created earlier, giving the train split as a parameter, 10 sentences to retrieve, the definition of the group, masculine, feminine, masculine, and neutral groups, and this will generate us this JSON object. So we have female group with its corresponding ID, male group with 3 corresponding IDs, and neutral group with 6 corresponding GEM IDs. Finally, we need to store the object in the JSON file. For that, we are importing JSON and running this little code here. In order to see our newly stored object, we need to refresh our directory. And here we see appearing the JSON file we just created. Okay, so now we are nearly to the end. All we need to do is to apply the process we described to the entire split. So here we are receiving the sentences for the validation split. So all the sentences for the validation split, we are running the filter, it returns true. We are getting the statistics on those sentences, and we see here the distribution, which is indeed biased. Then we are retrieving our groups, actual sentences belonging to each of these groups. We are creating the filtered object, and we are writing it. Again, we need to refresh in order to see it, and here we are. We see it appearing as a JSON file, and now we can download it and store whenever the place will be required.